All right, thank you very much, and thank you for putting this conference together. It's my first time at EC, and I'm really enjoying this. So I appreciate all the work. So yeah, thank you. I'm really excited to be presenting this joint work with Enrique, who's also assistant professor at the EC Business School. This is in Barcelona. So what are we trying to do here? We're trying to understand what is the impact of AI on knowledge work. And as the introduction to this session already emphasized, this is going to be quite controversial for many reasons. Here I listed two. It's not clear, being a different technology, probably more general purpose than other automation technologies we've seen before. It's not clear how much past lessons will actually apply to AI. So that's one. Second, as I already mentioned at the introduction, this technology is currently at its infancy. It's growing, it's improving very fast. We're all learning very fast how to use it. So it's not clear how much we can extrapolate from the current data about what's going to be relevant in 3, 4, 5 years. And we're interested in understanding the equilibrium effects of AI. Once this technology is widely adopted, it will probably affect the matching, the whole worker firm matching in the economy. We want to understand this mechanism, this general equilibrium mechanism, if you will. So in this paper, really what we're trying to do is provide a framework to do just that, to investigate what are the general equilibrium effects of AI and what's new relative to previous models of automation is that we're going to be very focused on what are the particularities of knowledge work and what are the particularities of AI, and this is going to differentiate us from existing models of general automation. Okay, so what is our approach more precisely? So we introduce automation in a canonical model of the knowledge economy, it's called. There is a nice, it goes a long way back tradition in economics to think about this knowledge economy. What is the knowledge economy? Well, it's of course what we do, but more generally understood is legal services, logistics, healthcare, consulting, finance. A big chunk of the modern economy is based on what we understand to be knowledge work. More formally, we'll think of knowledge work as work that the main input for production is going to be solving problems. So the main challenge here in order to produce is your ability to solve problems, right? And we'll see in the standard model, there's heterogeneity in terms of knowledge. What is knowledge is your ability to solve problems, okay? So we'll have humans and there's heterogeneity in knowledge in the population, right? We're going to look at competitive equilibrium in this setting. And in equilibrium, there's endogenous matching. So there's going to be humans matching with each other to produce as efficiently as possible, right? And we'll see that certain knowledge hierarchies emerge. And this is why some people call this literature the knowledge hierarchies of Vericano, because as you'll see in equilibrium, we'll see hierarchies, hierarchical organizations forming in equilibrium, right? So what we do is we'll introduce AI into this canonical setting. What is AI, right? I think it's a big question in any paper that claims to be doing AI. So what is it? What do you think AI is in this setting? So we'll think of AI as an algorithm that uses computing power, or compute for short, to mimic humans. Okay. So the guiding principle, at least for the baseline model, is we want to steer away from discussions about, well, AI cannot actually mimic humans. It's different in this, it's different in that. We can do that, and the framework allows us to do that. But at least for the baseline, we want to say, let us assume AI, there's these algorithms that will actually be able to do exactly the same as a human. And let's see where that takes us, and then we can relax this, right? So the main exercise will be to compare the equilibrium pre-AI, before there's this algorithm that can mimic humans, and post-AI. Okay, so all the results will be about how do AI changes the equilibrium relative to pre-AI. Okay, so I'll give you sort of the main results, and then I'll focus on a couple of results that, and I'll try to explain those carefully. But let me just give you sort of a brief outline of the main results. Before that, two definitions. I'll talk about basic AI and advanced AI. What is basic AI? Is AI that has the knowledge which is equivalent to a pre-AI worker, right? Those who pre-AI are doing routine work. And advanced AI is an AI that has an algorithm that has the knowledge of a pre-AI solver, a human that is actually a solver or a manager pre-AI, right? So these are two definitions: basic AI, advanced AI. And what are the main results? If AI is basic, then its introduction will increase the knowledge content of human work. So we'll see more humans specializing in solving hard problems, right? In being at the top of organizations. Less humans doing routine work. But if AI is advanced, the opposite will happen. So if AI is advanced, we'll see that once we introduce AI, there's going to be more humans doing routine work post-AI than pre-AI. And this has all sorts of implications for the distribution of productivity, of firm productivity in the economy, of firm decentralization, and so forth, right? And as I also mentioned in the introduction, when AI is advanced, when AI is very good, you start seeing firms that have scale with no mass. What are these firms? These are firms that are much more productive than the most productive firms pre-AI. They are very big, bigger than any firm pre-AI. But what happens is these firms are not employing a lot of people. They're actually renting a lot of compute to do a lot of production, right? So these are going to be firms that are very productive, very big, produce a lot, but with very few people. Now, this is one main result. Second main result is going to be about wages, right? So this first result is all about matching, what happens to the matching of different people, productivity, so forth. Then we look at wages, what happens to the equilibrium wages in the economy. So here we see several results. First, when you introduce AI, labor income increases, so total labor income increases. So if you were to take humans as just one unit, well, humans are better off in the sense of labor income increases. But there's heterogeneity there. So necessarily there's going to be winners and losers, right? What we show is that the winners are always at the extremes of the knowledge distribution. In particular, the most knowledgeable humans always win, and the least knowledgeable humans win if AI is good enough. Okay, then we do several extensions, which I won't have time to talk about today, but just for you to know. This is where we start deviating. Okay, now AI is going to be perhaps different than humans in some dimensions. The first extension is saying what happens in the baseline. We'll assume that problems are scarce. Being economists, we usually we're comfortable saying problems are scarce. So there's going to be a lot of compute in the economy, but not enough to be able to tackle all problems in society. We do the extension where actually now problems become scarce, and then we find that unemployment arises in equilibrium. And the second extension is one where AI is different than human in the sense that it lacks autonomy. Perhaps for regulatory reasons, we don't allow AI to take actions by itself. Then when this is the case, we find that actually all the wage of everyone can increase, right? So this, in a sense, when AI lacks autonomy, AI can lead to shared prosperity in the sense that the wages of everyone can increase, right? Okay, so this is a short talk, so I'm going to try to focus on these two results. First, what happens to the knowledge content of human work? Second, what happened to wages, okay? If you, so I'm very happy to talk offline about the rest, but I think that once we understand these two results, at least hopefully you'll if you want more, hopefully either we can chat or you can look at the paper. Okay, so I said the main exercise is to look pre-AI versus post-AI, so I have to tell you a bit about the pre-AI economy, right? And this is a place where I can respond to Nicole's question before about, okay, you're not going to give me any data, how do I know this is the right model? Well, at least we know that this model has been used to match empirical data of the 2000s, for example. This paper by Paul Antras, Luis Garicano, and Esteban Rossi-Hansberg, the QJ in 2006, uses this model to study offshoring, what happens when you allow international firms forming, and they show how what the theory predicts is very consistent with stylized facts in the data, right? So at least pre-AI, at least this model is consistent with the data. So let me tell you what this model is about. This is not our contribution. This is sort of a framework that is out there. So what is the model? So there's a unit mass of humans, each endowed with with 1 unit of time and some knowledge. So knowledge will be between 0 and 1. And there's some distribution of knowledge here. So we're going to allow so humans live in this line between 0 and 1, that's their knowledge. And we're going to interpret that as the fraction of humans you can solve. So if you're at 1/2, you can solve 1/2 of the problems that may arise in production. There's firms that organize production. It's going to be a competitive market. And what can these firms do? Well, one thing a firm can do is hire a human. And it's going to be a worker. What can the worker do? Use a unit of time to engage in production. Now, in production, a problem will arise. Without loss, we're going to assume that this problem is uniformly distributed between 0 and 1. And the worker may or may not be able to solve this problem. If the problem is harder than her knowledge, if the problem is higher than her knowledge, then she doesn't know how to solve the problem. She cannot produce. If the problem is easier than her knowledge, then she knows how to solve that problem, she can produce. Right? So if there's a firm that just hires one worker, that's all there is to it. Of course, firms will be able to do other stuff, otherwise it would be very boring. What else can firms do? They can actually hire solvers to help the workers that cannot solve their problems, okay? So in pictures, you can see that the firm I discussed was this one human here, it's one independent producer. Firms can also have a hierarchical structure where you hire certain workers, and the workers, when they encounter a problem and they don't know how to solve that problem, they can ask the solver, right? And the question is, okay, what is the cost here? Well, if you ask a solver, the solver needs to spend H units of time helping you, right? So H is going to be the communication cost. What that means is that if you are hiring workers of knowledge Z, how many can you actually manage? How many can you help simultaneously? It's going to be NZ, which is 1/H, 1 minus Z. 1 minus Z is the probability that each worker will ask a question. H is the cost per question asked, right? So this is continuous time. So the size of the teams will be given by this NZ. Now, these are going to be the two possible firms that arise in equilibrium. There's going to be positive assortative matching. So I don't have to be worried about firms that have workers of different knowledge. And what we're going to see is these humans right here that live between 0 and 1. Some of them are going to be workers, are going to be at the bottom of organizations. Some of them are going to be at the top. And what happens in equilibrium is that there's something called occupational stratification, which means the least knowledgeable humans are going to be workers. So roughly speaking, you can divide phase into something we'll call workers. They are either they are in the bottom of two-layer organizations, and these are going to be solvers. These are the guys at the top of the organization. And we'll have positive assortative matching, meaning the worst workers are matched with the worst solvers, the best workers are matched with the best solver, right? We can also have individuals hired in independent firms, but in this example, let me forget about that. So this is the model, okay? It's I understand it's very fast, but it's a very short talk, so what can I do? So what is our contribution? We're going to introduce AI. Okay, so now it's so far it's just this framework. We thought this is a very good framework to think about AI. So now here comes our work of, okay, how are we going to think about AI in this framework, right? So AI is going to be really a number between 0 and 1. So what that will mean is that if AI, let's say, is a half here, AI is an algorithm can mimic a human with that knowledge. Okay. I'll explain why we think of AI as one number instead of a distribution. But for now, bear with me, there's this parameter, the AI, between 0 and 1, that's the knowledge of our algorithm. Okay? So all firms have access to this technology. Now, to use AI, this algorithm, to replace a human, you need to rent 1 unit of compute, right? So we're normalizing the units of compute to be, well, in order to replace a human, you need 1 unit of compute. Okay? So that's our unit of computing power. Now, we'll be thinking of there's a large but finite amount of computing power in the economy. And in equilibrium, the rental rate of computing power will be endogenous. Now, as I said, we'll think of problems being abundant relative to the capacity to tackle the problems. We have an extension where we relax that. So these are the two types of firms we had pre-AI, right? I just discussed that. So now there's going to be three other firms that may arise, okay? First, there's going to be just you hire one unit of compute, just like you hire a human. You can do that. You could hire one human as a solver and compute to do your worker jobs, or you could hire human workers and compute as a solver, right? And these are really the only possibilities. So this in post-AI, there's going to be these extra three types of firms. Why not AI match with AI? Well, because all AI has the same knowledge. So if the AI does not know how to solve a problem, the AI on top won't know how to solve a problem either. So it doesn't make any sense to put a hierarchical organization just with AI. So far, so good? Okay. Yeah.
So do you need to have a notion of how surplus is divided between?
Yeah, I'm going there. Yeah, okay. So it's going to be competitive equilibrium. Right? So market clearing essentially will give you wages, yeah. Wages and rental rate of computing power. So before I show you a picture, let me tell you what is the main difference between human and artificial intelligence in this model. The main difference is that AI can be used at scale, right? So with humans, if you have a certain knowledge, you can only use that knowledge with your own time. With AI, once you have this algorithm, you can leverage it across all units of compute in the economy. That's crucial. And that's why we think of AI as just one number. Because you can think of many different algorithms, but because you can leverage every algorithm across all units of compute, the bad algorithms are going to be priced out. So that's one. Second, we're going to think of compute being very abundant relative to human time. Okay? So this second condition implies that even if you want to put all compute in the economy in two-layer organizations matching with humans, you're going to still, so even if you want to allocate as much compute as possible in these kind of organizations, compute is so abundant that you'll have to use some as independent production. So you'll have to use some compute just working on itself, by itself, right? So this is the implication of the second point right here. So compute is so abundant that some of it will actually, you cannot match all of it with humans because there's human time is scarce. So there's going to be some compute being allocated to independent production. Okay, so these two conditions imply that, well, there's this algorithm that is identical. There's this algorithm that is identical to humans with knowledge AI, and it's very abundant. That means that the wage of humans that are identical to AI is equal to their expected output, which is actually the AI. Expected output on their own. Why? Because AI is going to be used in equilibrium as independent production. Its expected output is the AI. So all humans with that are identical to AI are going to be earning their expected output, which is the AI, right? So if we go to how the equilibrium looks like, this is the pre-AI equilibrium, right? This is what I was showing here. We have workers, solvers, and now I'm showing you the wage pre-AI. What's going to happen here is, let's say AI enters as a pre-AI worker, it's a basic AI. The wage at that point is going to go down all the way to the 45-degree line. That's going to be their expected output, right? So once you introduce AI in this economy, the wage of humans that have knowledge, the AI is going to go down to the 45-degree line, and that's going to reverberate through the economy. And this is the post-AI wage, right? And also, you see how.
Why do you hire any workers less than ZAI?
Yeah, that's because problems are abundant relative to compute. So there's still things to do for everyone, right? If you drop that assumption, then those who are less knowledgeable than AI become unemployed. Okay, so this is a basic AI. What happens when AI is advanced? AI's knowledge is that of a pre-AI solver. Well, same thing happens, right? So at the AI, you drop to the 45-degree line, and these are the effects. Now, it's very interesting to look at these pictures and try to guess what's general, what's not. So that's what we did. And I'll show you in the 1 minute I have, I'll show you 3 fast results, okay? So how is AI used in equilibrium? This is sort of a lemma. If AI is like a pre-AI worker, it's going to be the best post-AI worker. right? So no human better than AI is going to be a worker post AI, and it's also possibly going to be a solver. In that case, it's going to be the worst post AI solver. Similar, if AI is advanced, then what's going to happen is necessarily the worst post AI solver, and possibly also a worker, and in that case, it's going to be the best pre-AI. I don't have time to discuss why that's the case. Let me show you first main result. If AI has the knowledge of a pre-AI worker, then what's going to happen is that the most knowledgeable pre-AI workers switch to becoming solvers. In that sense, there's going to be more humans that go higher in the organization and specialize in problem solving. The opposite happens when AI is advanced. And in the paper, we provide also all sorts of characterizations about what are the effects on matching, what are the effects on the distribution of firm size, productivity, and so forth. And then the second result that I promise you is what happens to labor income. So, as I said, AI necessarily increases labor income. So total labor income increases, but there's necessarily winners and losers. And as I said at the beginning, the winners are always at the extremes of the knowledge distribution. If the top of the best humans always win, the least knowledgeable humans win only if AI is good enough. There's a nice asymmetry here. Why is there this asymmetry? Very briefly, it's because when AI is very, very basic, what's happening is it's sort of substituting for the worst humans, and it's also making them worse matched. So both effects go in the same direction. But when AI is very, very good, it's sort of substituting for the best humans, but it's increasing their match. So this is the reason why the best humans always win, whereas the least knowledgeable humans might or might not. Okay, so let me conclude. I think I'm out of time. So these are main results. Let me not repeat what I said. I just think this is a very, very exciting area of research. There's a lot of uncertainty, but there's also a lot of work to sort of guide the discussion and think about the potential implications of AI for labor markets, which are potentially huge. Thank you.